Hello, I'm Valosek. Welcome to our poster. I have nothing to declare. Let's start with the introduction. Spinal cord morphometric measures such as cross-sectional area and anteroposterior diameter are commonly used to evaluate spinal cord atrophy, for example in multiple sclerosis, or to assess the severity of spinal cord compression, for instance in degenerative cervical myelopathy. However, the interpretation of these morphometric measures is challenged by the fact that the spinal cord anatomy varies between individuals. For example, females have smaller cross-sectional area than males. Additionally, the second challenge is that the spinal cord anatomy is changing across levels. You can notice the difference between the cervical and thoracic regions. The consequence of this is that the morphometrics are different across levels. Our objectives were as follows: develop a method for automatic spinal cord morphometric measures normalizations, and build a database of healthy normative values for 6 commonly used measures of spinal cord morphometry. Okay, moving on to the methods. We use data from the open access Spine Generic multi-subject dataset. The dataset was acquired on 3D MR scanners from 3 vendors across 42 sites worldwide. We used fast-spin echo T2-weighted images with 0.8 mm isotropic resolution. The images were reviewed by 2 experienced radiologists with a focus on the presence of spinal cord compression. This qualitative assessment revealed mostly mild compression in 64 out of the total 267 participants. Since our goal was to build a database of healthy spinal cord morphometry, we excluded those participants and ended up with 203 subjects. Processing was done using the Spinal Cord Toolbox, SCT, which is an open source library for spinal cord MRI data analysis. First, we segmented the spinal cord and performed vertebral labeling for each participant in their native space. Then, we computed 6 morphometric measures, namely, we computed cross-sectional area, CSA, AP diameter, transverse diameter, compression ratio, eccentricity, and solidity. Finally, we used linear interpolation to bring the morphometric measures from the participant's native space to the space of the PALM50 spinal cord template. This interpolation was done based on the number of slices for each vertebral level in the native space and the PALM50 template. Morphometric measures normalized to the PALM50 space were used to build a normative database for the whole cohort and separated by sex, and to create interactive figures supporting filtering for sex, age decades, and MRI vendors. Okay, moving on to the results. The proposed normalization method is available as part of the SCT 6.0 and higher through the SCT process segmentation function. You can visit the Spinal Cord Toolbox website and search for the SCT process segmentation to get more details about the method itself and about the normalization. Here we have an example of how the normalization can be used for a subject with spinal cord compression. The first argument to the function is spinal cord segmentation, which is used to compute morphometric measures. The second argument is vertebral labeling, which is used for the normalization. Lastly, we have to specify that we want to do per slice normalization to the PALM50 template, and we can also specify the output file name. The normalized morphometric metrics are saved as a CSV file and can be easily plotted. For example, here we have single subject metrics in blue and normative values for females in red. And we can see how the single subject metrics change at the level of compression. The normative database is open source and available in CSV format, 1 CSV file for each participant. This slide shows the mean and standard deviation values for the 6 morphometric measures computed across all 203 participants. The x-axis represents individual slices in the PALM50 template space from the C1 to T1 vertebral level. You can see that the figure is interactive, so you can easily browse through the metrics. If needed, you can also zoom for more details. Here we have the same 6 morphometrics separated per sex. Again, the x-axis represents individual slices in the PAM50 template space from the C1 to T1 vertebral level. As you can see, the interactive figures allow us to explore trends between sex. You can hide and show the traces by clicking on their corresponding legend items. Again, you can zoom to explore more details. Here we have an example of how the normative database can be used to normalize compression measures. The figure on the left shows the maximum spinal cord compression index, MSCC. This index is used to normalize the compression side using the non-compressed levels above and below the compression. However, MSCC does not consider the varying spinal cord anatomy across spinal levels. Thus, we proposed a normalization of the single subject measures by the normative values, as you can see on the right. Moreover, the healthy subjects can be filtered per sex to further mitigate the effect of sex. In conclusion, this study introduced the automatic normalization of spinal cord morphometric measures and computed normative values from a public database of healthy adults. The normalization approach is available in the Spinal Cord Toolbox SCT 6.0 and higher. To promote transparency and reproducibility, the presented results are open source, available as interactive NeuroLibre preprint. Thank you for your attention and stay tuned for the upcoming SCT course, which will be held in November this year. You can also download the latest version of the SCT, which contains the proposed normalization method and many more new features.